Hi, in this video we'll be looking at how to create your own animated material and use it with Easy Vertex Anim. First, we'll create a material layer and name it like something ML2. And then we will create a data set. And here we have a class for this asset, EVA material settings. Select. And we call it something like that. Now we'll open the data set, and the first thing we need to do is to link them together. So we'll put the material layer here in the material layer field. So this data set basically will tell the plugin which material layer it uses, and then the name and the availability of different material parameters, the textures, the UVs, etc. So the data set will link to the material layer via this parameter. And also, if you look here, there will be a asset tag, mat layer. And this way we can actually use asset registry. It's like a database that allows to search the assets. So when we have this material layer, we can find its descriptors. So it works both ways. So this way, when we open with the plugin a mesh with a material layer assigned, we can find this descriptor, and the plugin knows what's going on. Okay, and that's good. Now let's check this material layer. Here there is nothing yet in the plugin, as you remember. We have the UV channel, we have position texture, we have axis texture, and we have some other parameters. In the position texture, we store the location of the pivot. You see that? That's the position texture when I change the position of this pivot, it changed the color. And in the axis texture, we store the rotation. And you can see it here. The texture is updated. And we also can store something in alpha of those textures. So we basically need now to find it in the material, and we need also to tell the plugin how to find them in the material. So the plugin can update those things. So let's go into the material layer. I just keep it small like this for the moment. So we need to find those textures. In the plugin folder, you will have here EVA content. We'll have two subfolders, editor and runtime. And in the runtime folder, you have the texture folder. It has two small textures that are like templates for the position and rotation textures. So if I just take them here, they are also they are already correct type, etc. I can take this and convert that to parameter and call it, for example, that's the position, so I call it poi. Okay, poi. And this one I call it, that's the axis, convert to parameter, call it ax. Okay, cool. And now I have to tell the plugin and the descriptor, I have to tell that I have position texture and axis texture. and this one is called boy, and this one is called x to x. Cool. And here I have those enabled, or for the moment I will say that it's none. There is nothing in the alpha. Okay, very good. And now another thing I need to transmit to my material is the UV channel, which we will have here. And there's actually different ways to do so. So for example, I can just here say fixed or default to V1. Then I obviously need to put 1 here. And then that's enough if I just support one of each channel. And then, you know, to see something animated, we will probably just put some code here and we will continue it to test it like this. So here I took the scale animation from the previous part of this tutorial, this, and then I have my position parameter, and so I have to plug it here. So this position parameter obviously it's encoded in the mesh local space. Here we transform this position in volt space, etc. And here we feed the time, and then we scale the mesh. So to scale the mesh, I need to add here the volt position offset and plug it here. Okay, apply save, and we actually don't need the axis texture yet, so I will just check it. Now we can try to use it. We will go into the plugin, Anim layer, and we will put our data set. We can put it just like this, or we will search sudo, and there is an error. It says that the parameter control time is not defined. So if we check in our data set, it says that it has this parameter, control time, and this parameter is for the timeline here. But except this, you can see already our scaling animation is working pretty well, but we cannot control it. So let's go and modify our layer, and we will add this time control. The time control name specifies the name of a static switch parameter that we will use to switch between the normal material controlled time and the timeline controlled time. So if this switches to false, we will just plug our own time, and if this switch is true, we'll plug a parameter that will be controlled by the timeline. So here I called the static switch parameter TC and the time T. So in my data set, I will name it TC and the time T. And there's also delta time, which is used to avoid the smearing when you are scrubbing the timeline. So this is called DT here. This is also supported. It's optional, but it's looking better. And then I will just like move this here. And when I also need, of course, a previous previous switch node. Okay, so like this. That's the standard setup. The time will go to the current frame, to here, and to here. And the delta time minus delta time will go into previous frame. And those parameters here and this parameter here will be fed by the timeline, by the plugin. Now I'll start the plugin, and if I take my new data set, put it here, you can see there is no more warnings, and the timeline is working like this, and it also working like this. So now that we have seen all this, we can return to our UVs. Here we have specified fixed UV as 1, and it's not actually a parameter, it's just the same number as here, because in fact you cannot specify a UV channel as a parameter. So if I take, for example, text coordinate, there is no way to input here a number. So what we can do is to use static switch parameters to change them. For example, if I want UV2 and UV1, I can make a static switch parameter, which will be called like use UV2, and if it's true, it will use UV2. If it's false, it will use UV1. It will feed it here. And in this case, here I can say UV2 name. I put the name of this parameter. Just copy it here. And then that will work. And we also made a material function that you can use to enable any of the UVs. And this material function is very simple. It's just a big static switch with all the possible UVs, and then 1 by default. And in this case, you can uncheck all these checkboxes, and they are just called like the default, like this. Now we will be looking at which other information the plugin can encode and how we can to get it and decode it in the material. So first of all, simple things, we can encode the number of polygroups which is used in some calculation, like when you need to calculate the order of appearance of those parts. This is enabled with this parameter here, subobject num name, and then you give the name of the material parameter, and in the material you create the parameter of the same name, and the plugin will write it when you change it or when you save the material. Next, we have those two textures. That's the interesting part. Position texture, which encodes the position of the pivot, and axis texture, which encodes its rotation. And in both of those texture, in alpha, you can also save some information. For the position, you can save order, as we already seen, or the parent, if you have a hierarchical animation. And in the axis, you can save extent, which is more or less an arbitrary number you can provide, and also the order. Now let's see the other side, how we decode those data. For the position here, the position texture, we simply read it, and it gives us the pivot position local space that we can convert in word space or whatever. And this is a 16-bit texture, so it gives relatively precise float numbers, positive or negative. and that's enough. In the alpha, we can encode different things. Currently, we can encode order or parent. And both of those things will be encoded as an int. But here we have a float. So we have to use a function to transform this float into an int. And this is not just a cast, this is something rather complex. You can have a look here. And this is a predefined function coming with Unreal. So you have this HLSL code that transforms float into an int. And so once you decode it, you have the same integer number that you can see here. Like here we have 3, and you will have 3 in the here. And here we will not have 3. We'll have something completely arbitrary and different. Now for the axis texture, the axis texture in the RGB has the forward vector for the rotation of the pivot. So if we rotate this pivot here, for example, you see this red thing. It will contain the normalized forward vector of this rotation. So axis, this texture is a 8-bit texture. So here what we have is a number between 0 and 1. And the normalized forward vector can have components between -1 and 1. So what we do, we remap it into 0, 1, and here we have to unremap it. So here there is also a predefined Unreal function MS-pivot-painter to decode axis vector. And it's actually very simple. We have this constant by scale that basically remaps 0, 1 to -1, 1. And then we transform it to volt space and normalize. So for the directions for the vectors, you don't need to use camera relative space because it's enough. And you can also take this code and put it in here, because probably you need the local space of the direction. So here you can just from here have the local space forward vector. Okay. Then in the alpha of the 8-bit axis texture, we can have also two things: extend and also order. And as I said, it's 8-bit. So here we have a number between 0 and 1, but here those two things, extend and order, they are encoded as integers. And by the way, if you want to see them, you can choose here, for example, order. And if you want to see the extent, it's a little bit special. And it's if you choose something, you have this like a bar appearing, and you can change it like so. And you can also, of course, change it here. That's your extent. And this you need to multiply by 256. So you will have the same number, same integer number that you have here. So basically, if I have 126.7 here, on this side I will have 0.5, and then when I multiply it, I will have 127. So that's how this decoding and encoding stuff works.